The Sun, a 4.5 billion-year-old nuclear fusion reactor at the heart of our solar system. This glowing ball of plasma with a core temperature of 15 million degrees Celsius is a yellow dwarf star. In cosmic terms, it's nothing special. But for us on Earth, the Sun is vital. It holds the planets in their orbits and provides heat, light, and the energy for life. ESA's first mission to the Sun, Ulysses, was launched from Space Shuttle Discovery in October 1990. A joint mission with NASA, it was the first spacecraft to fly over the Sun's poles. Ulysses investigated the solar wind, the stream of charged particles emitted by the Sun. It envelops the solar system in a bubble known as the heliosphere. The mission discovered that the solar wind weakened over time and that the Sun's magnetic field reverses every 11 years.
4, 3, 2, 1, ignition, and liftoff of SOHO and the Atlas vehicle on an international mission of solar physics.
One of the longest and most successful scientific missions of all time, SOHO, was launched in 1995, and it's still going strong. SOHO has given us a new insight into the Sun's structure and interior, monitoring the output of solar radiation and providing the first images of the star's turbulent outer shell. SOHO has also transformed space weather forecasting, helping us to monitor violent solar activity from flares and coronal mass ejections. A major space weather event has the potential to damage satellites, communications, and power grids on the ground. Another mission that's helping us better understand the relationship between the Sun and Earth is Cluster. Flying in formation and in orbit for almost 20 years, the 4 cluster satellites are giving us a three-dimensional view of the Earth's magnetic environment and its interaction with the solar wind. Now it's the turn of Solar Orbiter. With its advanced suite of scientific instruments, it'll build on the work of these past ESA missions.
Our scientists have designed this mission so that they improve significantly their knowledge of the solar wind and what drives the solar wind, and as well what creates and generates the solar cycles.
The eventual aim of all these missions is to not only better understand our nearest star, but also predict its behaviour. Knowledge that'll help protect all of us back here on Earth.